Hello class. This is the beginning of your homework. Let's say the start of the lesson for the next day. Today we talked about proportions. We talked about similar figures, similar polygons. And we're going to recap with this polygon I have behind me, which is this quadrilateral, and then here this quadrilateral. We need to make sure they're similar. So the way to do that is to first, just being a recap again, to make sure each side is congruent. Okay? So we have here A is congruent to X, B is congruent to Y, C is congruent to Z, and D is congruent to W. And we can tell because if we look at these angles, these the number of bars represent that this is the same angle as that, that's the same as that. So we just have to pay close attention to that. Next, we'll look at our proportions of our sides. Now, you can do this by calculating, or you can just look at it. We'll look at side BC as compared to side YZ. Okay? BC is 8. YZ is 4. Okay? So, to get from BC to YZ, we multiply BC times 1/2, and that gives us YZ. Now, vice versa, we can multiply YZ times 2, and that'll give us BC. Okay? Because 4 times 2 is 8. 8 times 1/2 is 4. So we see that our proportion is going to be 2 if we're going from YZ to BC, or 1/2 if we're going from BC to YZ. Let's just go from the larger quadrilateral to the smaller one for these purposes. And we need to make sure every side has this same proportion. So let's look at side AB. Side AB is 6, and if we multiply it by 1/2, we get 3. So side AB is congruent to side XY, right? Or not congruent, I apologize. Should be similar to side XY because these angles inside this side are congruent. So YZ is equal to 3. Thus, these proportions are similar because if we multiply them by 1/2, or these sides are similar because if we multiply them by 1/2, we get the same number. Okay, class, let's look at our last two sides. We've compared side BC to side YZ. We compared side AB to side XY. We now have to make sure side AD and XW, have the same proportion. So again, let's take AD, and let's multiply it by 1/2. Okay? This is AD is 4, so we got 4 times 1/2, which gives us 2. Now, if XW is also 2, then we know side AD is similar to side XW. And XW, from what we can see right there, is 2. So AD is similar to XW. And then, as we had before, AB is similar to YZ. And BC is similar to YZ. Excuse me, I made a mistake. See, we all make mistakes. AB is similar to XY. Okay. And the last one we want to look at is side DC, which is and we multiply it by 1/2 because that's been our proportion. As long as they get this number here for WZ, then we know that DC is similar to WZ. So DC is 9. 9 times 1/2 is equal to 9/2 or 4.5. Same thing. Okay, and if we look at WZ, WZ is 4.5. This means DC is similar to WZ. Okay, now we know every side is similar because we calculated it, all have the same proportion of 1/2, or if we go in the other direction too, which means that these two figures are similar. Hi class, continuing from what I just talked about with the similar figure that we had with the quadrilateral, we're going to move on to what we're doing tomorrow. Tomorrow we'll be working with dilations, which either shrink or stretch a figure. So if we have something that looks like this and we stretch it, it's going to look like this. Okay, so we went from this to that with the stretch. Now this one, because it wasn't directly centered, was also moved as well. So we moved it up a little bit so it'd be in the center, and then we stretched it from the center. And the reason I say we moved it up is because we have to dilate it, which means multiply it by a scale factor. Okay, so if we multiply it by a scale factor, it's either going to increase, get larger like it did, or it's going to decrease. So this square, let's say the little one had 1 as a side. And it's a square, so one side is 1, all sides are 1. And this new one, this big square, had sides of 8. So that means we took this square, we moved it up, and we multiplied each side by 8. So we have 8, 8, 8, and 8 from 1, 1, 1, and 1. Okay? So tomorrow in class, we'll be working with dilations. So let's look at this first one that I have over here. Okay? You can't see it very well, but what it is a triangle. Okay? You got points A, 1, 2, B, 3, 3, C, 4, 1. Okay? And what we want to do with this triangle is multiply our x coordinate by 2 and our y coordinate by 2. Now just like that, when we multiply by 8, we're multiplying everything by 2. So we have a scale factor of 2. Okay? So we'll take our first point. And I'm going to use green for this. 1, 2. Okay? And we multiply it by 2. 2x, 2y. So we say 2 times 1. And then we say 2 times 2. This gives us the new point of 2, 4. We're going to call this new point here, we're going to call that A prime. Okay. Next point, B, is 3, 3. We multiply by 2. 2 times 3, 2 times 3. Okay. And then we get 6, 6. Going to call this new point B prime. Okay. And our next point, C, 4, 1. Again, we multiply by 2. So we got 2 times 4, 2 times 1, and that's equal to 8, 1. Or I apologize, 8, 2. We're going to call this new point C prime. I erase this now because I'm done with that. Now we'll plot these new points in red. Okay? So A prime is now 2, 4. So we go 1, 2, 1, 2, 3, 4. This is A prime. 2, 4. Our B prime is 6, 6. So we go 1, 2, 3, 4, 5, 6. Up 1, 2, 3, 4, 5, 6. So that's about there. And our last point, C prime, is 8, 2. So we go 1, 2, 3, 4, 5, 6, 7, 8. Up 1, 2. Right there. So this is B prime. 6, 6. This is C prime. 8, 2. Okay, and then we connect our points. And as you can see, I'm writing over my old points. And this just looks like a bigger triangle than that one. And that's all it is. We multiplied each point by 2, so now it's bigger than the previous one. Okay? So let's suppose, because we're done with that one, that's it. You know, they're still similar. They just are multiplied by a scale factor, which makes it larger. But my angles remain the same, and my sides are now proportionate because it's 2 times the smaller size. Let's say I want a new dilation. Okay? My dilation this time is d of xy goes to negative 4x, negative 4y. A prime is equal to negative 4 times 1, negative 4 times 2, which is equal to negative 4, negative 8. B prime is equal to negative 4 times 3, negative 4 times 3 is equal to negative 12, negative 12. And then C prime is equal to negative 4 times 4 and negative 4 times 1 is equal to negative 16, negative 4. Okay, so we know that, and you'll see that something special happened with this triangle. Okay, so let's start plotting our new points. And this one, because that one was red, I'm going to call this one, I'm going to make this one green. So first point is negative 4, 1, 2, 3, 4, negative 8, 3, 4, 5, 6, 7, 8. Next point, negative 12, negative 12. 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's about there. And my last point is going to be negative 16, negative 4. So I know I went 16, so I got negative 16 here, and down 4. That's going to be about there. So I connect my dots again. Okay, this triangle is similar to this triangle. But as you can see, like I said, something special is going to happen. It actually flipped over. Unlike this one, you just moved up a little bit because it got bigger. This one flipped and got larger. And that's because we have the reflection over the over this XY axis, and then we have an enlargement. The negative represents the reflection, and then the 4s make it larger, even though you would think they would get smaller because they were negative numbers. So this is our original, and this is our new triangle. We'll do this with several other shapes. We'll just start with this triangle because it's easy to see. One key thing that we'll learn today as we're doing examples in class, or not today, excuse me, tomorrow, as we're doing examples in class, is that this is similar to this, it's similar to this, it's similar to this, it's similar to this. These are all circles. And we'll prove that in class, that a circle is similar to a circle is similar to a circle. And we'll talk about why in class. So that's the key, because I want to know who did their homework, who went back and watched this video. When I come to class on Tuesday, because this is Monday night, you should be watching this. On Tuesday, my question is going to be, what are we proving today? And the answer would be, we're proving that circles are similar. No matter what they look like, all circles are similar. And if you can get that answer right, then I'll know you've done your homework and you'll be ready for the lesson today. All right, see you in class.